So again, we're using the first derivative test. We need to find the derivative. It's a quotient rule question. We have f, we have g. F prime is going to be 2x. G prime is going to be 1. Find our derivative. F prime g minus g prime f, all divided by g squared. Simplify. And we can simplify that a little bit more. And we can factor out an x on the top. With this derivative, we need to look at it a little bit differently. We can't just simply set it equal to 0, because by doing that we eliminate any of the possibilities for x that make the bottom 0. Give us an undefined with an indeterminate. So we're going to look at it in 3 ways. Look at all the factors on the top, all the factors on the bottom. So on the top we have this x. What will we plug into that x to make it equal 0? Well, 0. We look at the x minus 4 bracket next to it. What will we plug in for x to make that work out to 0? Well, 4. And the bracket on the bottom, x minus 2, what will we plug in there? We can plug in a 2 and make that equal 0. So the number line is now going to have 3 numbers on it. 0, 2, and 4. Now, looking at this, when we plug in a 0 or a 4, it'll make the top 0, so it'll make the function 0. But if we plug in a 2, that is going to make the bottom of this function 0, which if we have the bottom being 0, it's undefined. Or, in this case, since we're going to be talking about the graph, it'll be infinity. Now again, we need to determine what the sign is of this function in each of the now 4 sections that we have. So we've got -1 works there, 1 works in this section, 3 and 5. So f prime of -1, take a -1, substitute it in for x. Gives us 5/9, which is a positive number. Do the same thing with 1. Gives us a -3. Just in the interest of saving a little bit of time and saving a little bit of space, I'm going to omit the calculations at 3 and at 5, because by now this should be good enough, should know how to do this. So when you substitute in a 3, we get another negative. When we substitute in a 5, we get a positive. So now we can talk about the increasing, decreasing. This function's increasing twice, once from -infinity through to 0, and again from 4 through to infinity. It's decreasing twice, from 0 until 2, and then again from 2 until 4, and again we can't just put 0 through 4 because it actually stops increasing. The sign of the function goes to infinity at 2. Can look at minimum maximum. Well, we have a maximum at 0 comma something. Why 0 comma something? Because at 0 the sign of the derivative changes from positive to 0 to negative. To find out what the y-coordinate of that point is, we need to go and we need to find f of 0, the value of the function when we plug in 0. Just so works out that it happens to be 0 as well. So a maximum at 0 is 0. We have a minimum to this function at 4 comma something, because at 4 the sign of the derivative changes from negative to 0 to positive. So we need to find f of 4. Happens to be 8. So we have a minimum 4 comma 8.